look at the, because the moment I release, because of the weight, it starts moving down, no? And the action of weight. So I'm more interested in that, the green color. That's why I shaded separate here. So just show that the same diagram. We'll put it in another way. All these problems, I think, need some time, not like something seeing you can solve. I'll bring better diagram. Now, to make you understand, I'm just showing it thick. Let's get into. So this is our region. Okay, start looking at that green color region. Okay, now you analyze things here. Let's see that. How is the B bar? B bar for this second diagram, B bar will be out of the plane. We have stopped thinking like this creatively. What type of method we have developed? Question, answer, then key, then rank. So creative is lost due to this competitive exams. Almost everyone, even me also. Because I had to teach so fast, I had to cover so many numericals. We have stopped all these things. There's a major problem with our competitive exam preparation. And now let's see that what is the weight, the G will act the weight of this. So directly you put one red color arrow. It will start accelerating, no, because of that. So this will acquire velocity V. Okay, now B bar and velocity. So this end, if you take a positive charge, which is there inside, here will experience a magnetic force like this. Then positive charge will be induced on this face. The disk is having two faces. Then the deficiency of electrons here will get a negative charges. Then we'll get a electric field. And now you can ask question, sir, why you're not taking the weight of the electron will be negligible, no? Here. How long this drifting will take place? As long as FB greater than FE. The moment FB become equal to FE, no more drifting will occur and there'll be a potential difference. Okay, let it be there. I think none. What was our question? Acceleration due to gravity. So finally, what happens here? How to manage this question? No, the drifting of electrons will take place here. Then after this, what I do is like a, what is the, how do it will behave? Shall we say this is like a simple rod? What is the EMF induced across the faces? Should be equal to BVD. This is just equivalent to one rod. That's all. Treat just this like a rod. Then what is the EMF induced across it? That should be equal to, it should be equal to BVD. Then this will, the faces of the disc will behave like a capacitor. Q equal to CE. What is the capacitance of this? Epsilon naught pi r square D into BVD. This I'll differentiate. dq by dt. Epsilon naught pi r square dv by dt. So what is a dv by dt? Acceleration is equal to dv by dt. So this should dq by dt nothing but should be equal to I, no? So therefore this I is equal to epsilon naught pi r square bd. This is, yeah, only this much here. Both the d's will cancel out. Okay, this will be acceleration. Is it okay, our problem? Okay, now this is like a conducting rod, no? It will do experience. How the current will flow in it? I'll give better diagram. Weight mg, velocity, acceleration, current I. Then the force will be bi d. Here the magnetic field is okay. I think these dots are enough. You have to treat it in this way here. So what is a net mg minus bid equal to me? B into epsilon naught pi r square ba d equal to me. Solving for this, a equal to g by mg will be there. So m plus epsilon naught pi r square b square d. A few questions like current will it flow, sir? You're just asking the acceleration, that one. So finally, like this, there'll be drifting of electrons. Due to the drifting of electrons, there'll be current, and due to that current, again, it's expensive B ampere for we are discussing this one. Then with this, you look at the acceleration. Acceleration will because of acceleration will be constant. No, there'll be acceleration because of acceleration. It'll have V equal to AT. And look at the current. Current will be also a constant. In fact, practically it happens. So what we are studying is something at a very low level. So maybe if you go for Olympiads, no, they may dump with all this stuff of this kind.